All right. Welcome to the Wrench Factor, where we explore technologies and innovations shaping the future of industrial asset management. We talk with leaders who are in the field every day so that you can learn what actually works on the plant floor. Today, we're diving into a new era of vibration monitoring and what industrial leaders need to know. So, a quick note before we get started. Last week, MaintainX announced a formal partnership with Weights. We're excited about what this means for customers who want modern vibration monitoring tightly connected with their maintenance workflows. And we'll touch on that as we go. But I'm joined today by two guests from Weights. Ryan Bowman is the Chief Revenue Officer, and David Porter is the Director of Reliability Services. Ryan, Dave, thanks for joining.
Hey, Nick. Thanks a lot for having us.
Yeah, absolutely. Happy to be here.
Awesome. Well, let's start with the basics. For leaders who don't live in vibration day to day, how do you explain what modern vibration monitoring is and why it matters?
That's a really good question. So vibration has been around for a long, long time, and try to keep this a really short and high level. But there's two kinds of vibration. Everything out there is vibrating all the time for one reason or another. One type is natural or resonant vibration. I'm sure you've heard of that. Like you strike a tuning fork and it rings. That's just natural frequency. But that's not what vibration analysis is. Vibration analysis, as we know it, is caused by forced vibration. And that is, you can never perfectly balance anything. So a rotating machine has a little bit of unbalance. So that causes that forced vibration. And the great part about it is it's just physics. And everything that is a component on that machine has specific frequencies that we can identify and analyze. And certain faults provide certain patterns in the vibration. So we basically can identify what the fault is in the machine by analyzing that vibration.
Love it. And so, Ryan, how do you tie that back to what a plant manager or VP cares about in terms of numbers?
Yeah. I think first and foremost, when you think about predictive maintenance, it reduces unplanned downtime. We like to say we want to create a world where nothing breaks, at least unplanned. So catching issues early gives teams time to actually plan repairs instead of reacting to failures. And even avoiding a single major outage, can pay for basically an entire predictive program. Second thing is it lowers maintenance costs. So planned work is always cheaper than emergency work, and organizations see less overtime, fewer expedited parts, and better use of skilled labor. Third, I think PDM improves inventory and capital efficiency. So when failures are predictable, moving to that more predictable or prescriptive model, teams don't need overstock spare parts. Catching issues early helps extend asset life and delay large capital replacements. And then finally, improving predictability. Fewer surprises means more reliable production, better OEE, better forecasting, higher confidence across operations. So when you put all of that together, it becomes kind of a no-brainer. We often see ROIs of 3 to 6 months through cost reduction, risk reduction, predictability. And that's why PDM is kind of blown up. And consistently delivers strong ROIs, both for leadership, but also at the facility level.
Love it. Well, you've both seen the evolution of this technology over the past couple decades. And how different is the world today compared to the old route-based approach?
My God, it is so different now. So 20, 30, 40 years ago, again, vibration's been around forever. At the beginning, you might have a guy once every 6 months, or guy or gal, wheel in a pallet full of equipment and hook up to things and take readings, and then go back with a ticker tape or paper tape and try to read those. It's printed out on a piece of paper. So you literally had very heavy, large equipment you had to wheel around, and readings of it once every 6 months or every 3 months. Then fast forward a little bit to route-based data collectors like the CSI 2110, 2120, 2130, now the 2140. That made all that equipment much easier to handle. You could just walk around with it instead of wheeling it around. So that allowed for people in the plants to walk around and touch many more pieces of equipment much more often. But you still had to walk out there, put the sensor on, collect the readings, and then go back, download your readings, and do the analysis, and all manual. And then fast forward to IoT, which is exciting, where the industry is going now, is we have remote sensors. We just glue them on the machine, and instead of taking a reading every 3 months, or at best once a month, we take readings every hour, in full-time waveforms, FFT readings every day. So you're going from taking us like a Polaroid once every month to almost having a movie of how your vibration is happening on your machines. That is pretty exciting.
That's cool. I wonder if I could use that to get out of a speeding ticket. It was a route-based, looking at my odometer on a route-based level.
Right.
Well, what does that unlock in practice when you go from once a month to multiple readings an hour?
I think the biggest thing is there are things that might happen faster in between those readings that if you're taking them every hour, you're going to catch them. So not only do we see faults that happen a little faster that we can catch where you normally wouldn't catch with vibration, we also can see just the process variation of the machines. And that's actually part of the learning process of IoT monitoring is you see that full spectrum of how the machine runs. And you kind of get a baseline of that. You kind of get a footprint. You set your settings and baselines around how the machine runs, and you're off.
Yeah, and you're watching it consistently as well, right? So you may be seeing an anomaly on a route base, but then you have to go back and check it again all manually. Where with a system that's running all the time, you may catch an anomaly. You want to track that closer over the next couple of days or weeks, do different analysis on it. It's just giving you, it's the next iteration of how to do predictive and then move to a prescriptive based program.
Makes sense. And I've seen customers of ours that are still doing route based as well. So it's not dead. It's still very much a real way of doing things. Can you talk about, you have any examples or customer stories you can share with folks? Just give them some context of an example where they, that continuous view helped them avoid a major problem.
There's one big one that springs to mind. It was a several $1 million save on, I think it was overseas, on a ball mill. It is very slow speed, so it's a huge challenge for vibration to begin with. But because we were taking so many readings so often, so our normal vibration every hour and temperature every 15 minutes, we saw the anomaly, wrote it up, sent it to them, and turns out there was a bad bearing on this ball mill, and they were able to plan and schedule the repair versus the downtime. Downtime would have cost them millions of dollars because this is old equipment, no parts in stock. They would have had to order the equipment. It was like a 4 or 6 month lead time, so it really saved them big just by having continuous monitoring.
That's incredible. When you think about fit, like, is this who's right for this sort of thing today? What are the signs that a plant is ready for modern vibration monitoring and is leaving money on the table by not doing it?
I would say some of the things that Ryan already pointed out. If you have unplanned downtime, break-in work, bad actors is a big one. You have the old 80-20 rule, right? 80% of your problems come from 20% of your equipment. Right. So you always have a list of bad actors, and continuous monitoring can really help identify the problems with those bad actors. We also assist with, we give plenty of information towards root cause failure analysis. That continuous monitoring can really help that. But basically, those are the things. If you have high maintenance costs, break-in work, a large inventory in your storeroom because you have those things, the continuous monitoring as well as other maintenance best practices can really reduce those costs.
Yeah, and I would add, if you have rotating assets, right? Simple as that. But then also I think you have the challenges that come with, a retiring workforce or knowledge leaving the facility. That creates a lot of challenges that can be solved with predictive as well. So there's a lot of different aspects and a lot of different value, but really if you have rotating assets and you care about output and OEE and want to do more with less, and that's what we're seeing across the board with labor shortages, what have you, you're able to repurpose the folks that are going around doing manual checks to actually do the work that they, that actually have an impact on the results. And that's ultimately what we want to do is have the person be able to turn the wrench to fix the thing, as opposed to be trying to diagnose it or trying to figure out what they need to fix next. It's considered, the greatest maintenance planning tool ever, when it comes to that type of thing.
Yeah, that makes sense. Cause I know there are some guys out there who literally can drive around their plant, or just walk through, and they've got that ear, they can hear something off.
Yep.
So I'm glad you bring up that knowledge, gap, or that retirement gap, the labor challenge of it as well, because sure, if that guy's there awake 24 hours a day, you might catch something, but eventually that expertise and that knowledge is harder and harder to find these days. So it's a good call out. And when you think about, like, you got some leaders listening to this that say, hey, that kind of sounds like us. What's a sane way for them to think about starting without, do they just need to go put stuff on all of their assets on everywhere across their plant? How do you kind of frame a business case and a process to get started here?
Yeah, I think, first I'd like to start with maybe some things to consider, right? I mean, like we said, if you have rotating assets and you're looking at increasing efficiency, right? This is a good place to start in terms of predictive. You're going to see a strong ROI quickly by deploying sensors. It's like moving, from kind of horse and buggy to a car. I would encourage people considering an IoT predictive strategy to closely evaluate a few key things when looking at this. If this is a direction you want to look at, the first thing you want to look at is the hardware itself, and the companies that you're going to be partnering with experience in your specific industry. So when it comes to predictive, everything starts with data quality, and that begins at the sensor or the hardware level. So PDM is not a one-size-fits-all problem. Different assets, different speeds, environments, mounting constraints, they all require different sensing approaches. So the sensors themselves, can they physically fit the asset? Will they stay mounted and protected? Does it support slow speed or variable speed? Is battery life measured in months or years? Can the battery even be replaced? How much networking and infrastructure is required? Does it take one gateway or 20 for your facility? Will it survive long term? These are all really good questions to ask. And then ultimately, if the sensor, can't collect data that's consistent and reliable over time, everything breaks down. And when you think about route-based, you got to, sometimes organizations are wondering if they even did the analysis on the machine. When was the last time? Did we forget to check that? You don't have any of those issues, with good hardware. So, ultimately, I think the key is not all sensors are created equal, and that's a really key consideration. The other consideration is, how the organization turns data into action. And it's the idea of kind of alerts versus action items. And this is where a lot of PDM programs struggle. I think there's a misconception in the industry that AI alone can solve this problem. And I think we thought that early on, right? We've grown over the last 20 years through the school of hard knocks, and have learned kind of the hard way that there's a huge human element to this. AI is great at identifying anomalies, but without context, that anomaly detection creates a mountain of work, and it's ultimately busy work for a facility that's already overloaded, right? That's the opposite of what we want to be driving. So the real value in PDM comes when insights actually drive reliable action at the facility level. And that's the key to actually building trust at the facility level. Because if you don't have the trust and the people aren't actually using the data and turning the wrench and doing the action that needs to happen, none of this matters. So once you get that, you can really deliver, like I said before, a 2 to 6 month ROI by reducing that unplanned downtime and all the other benefits. So I would really encourage leaders that are interested in this to look closely at two things: the hardware, and then if the vendors are going to provide alerts versus action items, and really have that closely knit human element to be able to be prescriptive, not just predictive.
Love that. Because I know a question I see from our clients a lot, they'll ask me is there's a lot of offerings out there that say they can do that. So if someone's like, I want to look into doing predictive maintenance with vibration monitoring, you look that up, there's a dozen folks plus that, they could see that, to an untrained eye, they could all look they could look very similar. So, but you mentioned, not all sensors are equal. What should they be looking for? What are some things that should stand out to them? And where do you see that kind of differentiation is important versus some of the things that are maybe, those are kind of similar? How do you kind of help folks work through that differentiation?
I'll take a couple stabs at it, and then Dave, maybe you can chime in as well. But I mean, ultimately, the reliability, the durability, and the experience of those sensors in the environment that you're going to be deploying them in. A sawmill is very different than a building materials, than food and beverage. They're all unique challenges. Is there going to be a wash down environment? Can the sensor handle those chemicals? These are all things that you almost don't learn until you see them. So those are huge aspects. And then the ability of the sensor to be able to get very deep and rich vibration data when needed, whether it be able to do slow speed or variable speed, as I mentioned before. But you need that quality and that breadth. And you really want to ensure you have the trust in that organization that they know your environment, that they know your industry, and they can handle those environments. Dave, would you add anything to that?
Yeah, I think the biggest thing would be make sure that you have a vendor that's going to set you up properly, be vested in your success, not provide just a one-size-fits-all solution. Because like Ryan says, every factory is different. All machines run differently. And you want to make sure that you have the people, not just AI doing everything, people there hand in hand from the start to the implementation and setup of the entire thing. I think that's the differentiators.
Yeah, that makes sense. A lot of teams get excited about integrations, but we know there's a big difference between checking a box once and building a workflow that actually sticks and drives value. How should leaders think about integrations between vibration monitoring systems and tools like their CMMS or other platforms so that it becomes a long-term efficiency lever and not, one-time IT project?
Yeah, I think that this is, a critical component, right? Because ultimately, we want people to actually leverage the data. And so we want to meet people where they are. So deep integrations with the CMMS tool that they're leveraging is key to be able to get the data to the people at the time that they need it to be able to schedule, do the work, make sure the work is completed. So, we've worked really hard and we're really excited about the partnership with MaintainX specifically to be able to help create a world where nothing breaks by getting the data in the right way with the right hardware, with the right sensing technology, reviewed by the right analysts and AI to identify the anomalies, the analysts to really be able to be prescriptive and go full service with the customers from problem to validated resolution, but doing that in the technologies that they're leveraging on the maintenance, on the facility floor. And so, that's where we see, these integrations being critical to the success, both short-term and long-term.
Couldn't agree more. Yeah, I think it's important for folks to try to figure out how do we help support people where they're at and make sure that the data can flow seamlessly back and forth, because systems like yours benefit from that, like the closure and the information that comes from that diagnostics, right? So your system gets a lot smarter and more robust if you're able to get that data back, right?
Yeah, absolutely. I mean, we're validating the impact, right? So we go from start to finish. We identify an issue, we prescribe an action to be taken, go do X, Y, Z. Then we watch and continue that until we have the desired impact or result that we want to see. And then obviously our system is learning constantly. Over 10 billion readings per day. We're over 1 trillion readings in general. We're approaching 1 million sensors. That's a lot of data to be able to continuously leverage to make sure that our system is best of breed in terms of understanding what something means and then prescribing the right action. But again, that integration then takes it to the next step where the right data gets to the right person at the right time consistently.
Love that.
A true reliability partnership, not just
yeah, exactly. We really pride ourselves. It really means something to us. We have the term customer delight, and that's it's integral to the way that we've structured our business.
Love that. As we're getting close to the wrap here, I want y'all to put your sort of future hats on and think like, what's next for vibration monitoring and predictive maintenance. Like, what does that next era look like to you all? And how should leaders of these operations prepare so they're not playing catch up in 3 to 5 years?
Dave, you want to take that one?
Yeah, I think from the advancements in technology that we've seen in a short amount of time, like I said before, it started with big equipment, then it went to the route collector, walking around, and now it's just a sensor we glue on. AI is brand new to everybody. I think we're going to see some AI advancements that help our efficiencies, maybe help with some data in the background. I think one of the bigger things that we're going to see is just more edge processing on the sensors and sending the right data. Right now, a lot of sensors take overall data and send it to a website for machine learning and AI to interrogate, as well as our analysts to interrogate. And then we write up our reports and send them out. I think we're going to see, and it'll actually help with the number of sensors and gateways that you can utilize as we move down that advancement in technology with more memory on the sensors to do that edge processing. You can transmit a lot less data versus like the overall data we send now. So you can do the processing on the sensor versus sending it to the websites.
I also think you're going to.
Go ahead, Ryan.
I also think you're going to see some more generative AI come into play. This is something we're working on now. We're excited to get this rolled out in 2026. But the ability to have all of the information about your assets from all the data that we're collecting, and then be able to ask questions back to our system about that. Hey, what's my highest performing motor? What's the motor I've had the most issues on across all my facilities? Having a conversation with your weights data allows you to turn that, all of the wealth of data and information that you have about all of your maintenance practices, what facilities are performing better than others, what practices that you've implemented that had what result, whether you implemented a vibration analysis or whatever impact that you guys have done. You'll be able to track that impact and ask questions back to the data. That's something we're heavily looking at for 2026 and beyond.
That's awesome. I think that's one of the most powerful things that Gen AI can do for folks today is take them away from having to become software or data experts. And if they know the right questions to ask, or even maybe if they don't, they can help surface the right questions to ask so they can actually use that data in a much more powerful way and make it more accessible. That's something I personally get pretty excited about because I think there's a lot of potential there.
I do too. Yeah.
Awesome. Well, Ryan, Dave, this has been great. It's a lot of fun. Thanks so much for joining and breaking down what modern vibration monitoring really looks like in the field. My big takeaway is it's not necessarily about, adding more gadgets, things like that. It's about getting earlier, cleaner signals on your most important assets and turning those signals into better planning and more stable production. So if anyone watching wants to learn more about how MaintainX and Weights are working together to bring vibration insights directly into your maintenance workflows, we'll put a link in the description there or in the comments. And thank you all so much. The Wrench Factor is live every other week, so please subscribe wherever you get your podcast, and we will see you all next time.